Okay, so the first case study we're going to do is looking at the roadkills data. So we looked at the roadkills data already. Quickly, we looked at the distance from the park and the number of roadkills. But this time we're going to explore that data more fully. And then the next case study, we're going to have one that's a press-on rate. So this is going to be a press-on regression. The next one's a press-on rate. So let's go over to R. Here we are. Okay, so we've got, oh, I've already spelled something wrong. Road kills. There we are. Right, first of all, let's read in what we're going to need. Tidyverse, tidy models, GGLM. All loaded. And let's read in the data. So let's have a look at our data set. So what we've got is they've gone and they've measured, they sort of took little 1 kilometer areas and they looked at the number of roadkills. We have the X and Y coordinates. This is a particular amphibian they're interested in, but this is the total number of roadkills, and they've got a whole load of measurements. But we're just going to focus on distances to make it nice and easy. So what we're going to do is we're going to grab the total number of roadkills and anything that starts with D, so that's going to get us all our distances. So let's have a look. So we've got a total number of roadkill, we've got our distance to the water reserve, distance to the water course, distance to the park, which is the one we looked at before. And let's have a quick skim and see what we've got. So let's have a look. So we've got 52 observations altogether. Now we've only got 4 columns. The columns are we've got the total number. It's absolutely complete. It's got an average of 25.9 roadkills, a standard deviation of 24.3. The minimum is 2. The Q1 is 7, 17.5, etc. And we've got the distances. So all good to go. So the first thing we should always do is always have a look at our response variable. So we've basically done a bar chart here, and you can see that we've got quite a lot up here, very right skewed, very typical Poisson distribution, that sort of right skewed behavior. Some as many as greater than 100, which is a real shame. So what we're going to do now is we're going to look at the relationships. We're going to put each of our distances on the x-axis, our number of roadkills on the y-axis, and have a look at that and see what patterns we've got. So here we are. Let's have a look. So first we can see as the distances goes away, we decrease. Interestingly, the distance from the park, we didn't see this as much last time. I didn't mention it in the last video. We've got almost what looks like a cubic relationship there. It sort of goes up, it really drops off, and then you've got this extra sort of recovery. Why, I don't quite know. This one, we've got more of a quadratic. It goes up and then it drops off. This one, again, drops, bit of a peak, and it's probably being driven by this one single number here. I mean, this is a bit of an outlier. It's probably messing up our results and then it drops off. So they're the patterns we're going to do. So let's start with a full model. So what we're going to do is we're to GLM, because we're doing a Poisson. We'll let it know it's a Poisson, we let it know it's data, and all I've done here is I said the response variable is total number, and basically everything else is a predictor. So we'll fit that model and have a look. And what we're going to do is we're going to use p-values to decide if we should keep anything. So we see that distance to the water reservoir, yes, significant. Distance to the park, but the distance to the water course, it's not significant. We've got this 0.406. So I'm going to remove this as a predictor because it doesn't seem to be a significant predictor. We could just redo the model, but what I'm going to do is I'm going to use the update function, which is a way of quickly updating models, both linear models and general linear models. So I take that model, my new model is called model 2. I've got a dot here to say I want the same response variable, I want the same predictors, but I just want to minus the water course. So I run this, and we have a look. So we can see we've got a significant water reservoir, significant part, etc. So this looks good. These are significant predictors. We can say, is our model any good? As in, should I add more in? And we have a lot more predictors that we could put in there. Not going to, but we could do, but we could check it. Remember, one of the ways we could do it is we could look at our residual deviance and see if that's still significant. So we do 1 p chi-squared. Here's our observed residual. Here's the degrees of freedom. And we get very small. So yes, this model is not explaining everything. There's still a lot of variability in that response variable not explained. And as I said, there's lots of other predictors we could put in that if we wanted to, but I'm just going to focus on this. So the next thing I do is I'm going to say, can I improve my model with just the predictors I've got? So what we could do is we could see if there's any sort of patterns still in there. So I'm going to grab my residuals. I'm going to use the Pearson residuals. I'm going to add this. So I'm going to add an extra column. that's going to have the residuals for the M2 model. So if I actually look at roadkill, all I've done is I've added this extra row here. What I'm going to do now is I'm going to plot the residuals versus, first of all, to the water and also to the park. And what we see if we look at these two is, so these are the residuals, so really we'd like random scatter. This is not too bad. It's a bit of deviation away, but okay. But I'm more concerned about this one. There definitely seems to be a pattern still here, doesn't there? It's definitely a cubic pattern. So I'm going to incorporate that. So here's my model now. I've got the number of roadkills, distance to the water reservoir. I've got park, park squared, park cubed. So I've added in a cubic. Let's have a look at a summary. Well, all those polynomial terms are significant, which is interesting. The other thing we could do is we could always look at our AIC to see how our models are doing. And definitely we've got a really small AIC with a cubic. So I think the cubic needs to be in there. I'm going to leave it in there. The other thing we do is we can now check our new residuals. Still a little bit of deviation, but not bad. That's still got reasonable random scatter against there. So let's have a look at what our fitting model does. So what I'm going to do is I'm going to create some new data where I've got a distance all the way from the park from 0 up to 25,000. So what I'd like to do is I'd like to look at the distance from the park on the x-axis, put my points in that we've already seen, and then add in the fitted value for my new model. Now the model needs also water resistance, so I'm just going to cheat and I'm just going to set this to the mean. So I'm just going to say, let's assume that we've got the mean distance to the water reservoir to see what that's like. And now I'm going to add, I'm going to do predict. Here's my model, here's my new data. And I say I want the type response, because if you don't, it would give you the log of the yi. I want the actual yi, so I just say type equals response. So if I run that, what I should get is some new data that looks like this. I've got the distance to the park, the distance to the water reservoir is all 704, because that's the mean, and here's my fit. So now I'm going to plot this. Basically, I'm going to do the distance to the park and the total number with the roadkill. So basically, it's this plot we've seen before. But now I'm going to add in a line. I'm going to say the y-axis is the fitted. And look, I said, well, actually, you go and find it in this data frame. There's some new data that will give it you. And here's our model. Nice little cubic. Still not getting all the points completely, but not a bad little model for predicting that. So there's your first Poisson regression. We looked at just the distances. We could have put so much more in there. We first of all trimmed our model by looking at the predictors that weren't significant using the p-value method, which is, as we'll see in a couple of weeks' time, is what we call a backwards type method using the p-value. Once we got that, we looked at the residuals and said, there's still something not been explained. I knew there was other predictors. I could have gone and looked at the other predictors, but I wanted to make this model nice and simple with just the distances. So I looked at the residual versus each of the distances, saw there was still quite a significant pattern in the ones for the distance to the park. So I added in a cubic. This is looking really good. If you're saying, well, could you put more polynomials? Could you put in to the 4 to the 5th power? I actually tried that before I showed you this and found that once I put that in, it wasn't significant. So cubic I found out was the best way of doing it. And then once I got my model, I use it to be able to predict those mean roadkill at that point. So that's it. Next time, we're going to look at insurance policies, if I remember rightly, and we were doing Poisson rate regression. See you next time.